Hi everyone, this is Professor McAllister. I'm here with one of the pioneers and innovators from Nebraska. Can you introduce yourself, please, sir?
So I'm Jim Jeffries, currently IEEE President and CEO. Graduated from University of Nebraska in 1968. Spent my career as a manufacturing engineer, telecommunications equipment, cable and wire. Had a significant opportunity mid-career to work in fiber optics, converting a copper cable factory to all glass over a decade, and introducing the first fiber optic cables that we produced at the Bell system.
So we've moved from copper wire, twisted pair, to where we are now, wireless through fiber optics technology?
Well, the whole idea of fiber optics was speed.
Okay.
You know, and we had no idea when we started. Originally, it was to be a tenfold increase in capacity. Fibers handling high quality digital communications, but it was intended originally for point-to-point communications. And the ideas that we would have today with fiber optics all over the world, every server connected, every network connected, every cell phone tower connected with fiber, was not in the plan. But as evolved, and it's been amazing to see the evolution of technology that makes fiber optics what it is today.
Now you said that you go back to in 1960s, so there was many frames and mainframes, right? The IBM 360.
Yeah,
perhaps,
yeah.
And then we migrated to the 80, 286, 386, 486.
You can go all the way back to the 8080. You can go back to the 8008.
Right.
You know, and in fact, the first computer that I designed was for resistance testing of copper cable. And computers were too expensive, so I did it with medium-scale integrated circuits. An adder circuit, a counter circuit, comparator circuits.
Yes.
You created your own solution for a digital multimeter.
So a lot of this has to do with half adders and full adders, right? And what do you do with that carry digit, right? Because we deal in base 10 arithmetic. So we have to recycle once we get past 9 to 1, 0.
Yeah.
And then it increases by powers of 10 it is? It's a 10, base 10.
So originally what I did was all in base 2 countdown circuits.
Right.
So just binary countdown until you had a comparison, and that was enough.
That's incredible that we have to change base systems. Now, is it possible to design a computer based on base 3? Minus 1, 0, and plus 1. I believe that the brain operates that way.
Yeah. So it's been interesting. I don't know all the evolution of computers, but certainly the idea of staying in base 2 and using RISC, reduced instruction set computing, provided the foundation for big changes. And now RISC continues to be critically important, in computers today. Of course, the next step may be quantum computing. Where we actually have multi-states.
Multi-state. Have you ever met Robert Noyce?
No.
I read about him.
Yeah.
He's a great man.
Yeah.
How about
we have a medal named after him at IEEE that we award every year for semiconductor improvements.
How about Tim Berners-Lee?
No.
But you know what he did, right? He developed the HTTP protocol.
Yeah.
Which is amazing stuff.
Yeah.
Absolutely. Now, your insignia. You showed me your insignia earlier because we were talking about inductance, RLC circuits, the right-hand rule.
Our little IEEE logo here, which we adopted. IEEE was formed in 1963 when the power engineers and the radio engineers got together to form IEEE. And our symbol was a kite representing Ben Franklin's original electric experiments, which we marked with a milestone plaque in London. And in the center is the right-hand rule, describing fields and flow of current.
You know, I have a book by Ben Franklin. Did you know that he did a lot in Pennsylvania in education? He was more than just...
He was everywhere. He was everywhere.
And he also came up with the university scheme of a provost, a vice president, and the roles of each position.
Yeah.
It's just an incredible book.
Yeah.
And what's the name again?
Jim Jeffries. And we've got to get into a presentation now, so thank you very much.
I'm going to videotape that.
Okay.
I got you okay?
Okay.
Thank you.
Yeah.
It's a pleasure.
Yeah.
Angel Grant, Director of RSA Identity Fraud and Risk Intelligence.
Yes, I've been hearing that encryption theory has gone way beyond visionary cycle, prime numbers, and wiretapping that they used to do back in the day, right? So now, is it easier to wiretap a wireless path?
Well, first off, crypto is back in vogue these days because of the explosion of innovation and technology, such as the panel we just had on IoT, where you now need to protect and encrypt more traffic than ever before from the edge to the fog to the cloud, and think about how to encrypt and protect that, but not only that, but protect the data that goes along with that and the packets that go along with that and the logs, both structured and unstructured, and encrypt that in a way that cyber criminals can't use it and make it useless to them so they can't monetize it.
Makes sense.
So the business models have changed, which has been driving the need to innovate with encryption and the whole crypto space to be more sophisticated.
So you can't really decipher content if you don't understand what it means. That's what you're saying.
Right, and that's the advice we give to organizations is classify your most important data. Encrypt it, make it completely useless, because if somebody steals it and they can't do anything with it, they can't monetize it and commit crime with that. So that is the value of the resurgence of the popularity of focusing on the crypto implementations.
So do you take into consideration circuit switching and packet switching?
You need to consider the entire IoT continuum, including circuit switches, packet switches, anything that can be intercepted. One of the things we talked about was the fact that cyber criminals are targeting organizations' processing powers so that they can do things like cryptojacking. So basically leveraging that processing power to mine cryptocurrencies. And in order to do that, they need to leverage that processing power. So if you design it in a way that they cannot leverage that processing power, you prevent them from hijacking your systems and infrastructure to create that botnet to do things like cryptojacking.
Because right now we're at the 5G, fifth generation stage, the Internet of Things, with smart devices everywhere.
That's right. Yeah.
My goodness.
Yeah.
Okay.
It's a fun time to be here, and
really
lots
is.
of cool innovation and applications.
Well,
but
especially pioneers like me, who are not given the recognition. Because that was my major, electrical engineer in 1971, and the first microprocessor came out in 1972.
Okay.
With so many transistors on them, you know.
Yeah, there's sensors everywhere now, and transition. And the application and business use cases of that are just exploding. And someone who's pioneered that space, you probably see so much opportunity for those applications to be leveraged. That's kind of cool.
Well, you also have what was that? Photolithography to etch a lot of these circuits, which is just incredible. Yeah, right.
Yeah, lots of cool innovation.
So it all goes back to the basic transistor.
That's right.
Operations per second.
Yep.
Thank you so much. What's the name again?
Once again, this is Angel Grant, Director at RSA for RSA's Identity, Fraud, and Risk Intelligence Solutions.
Thank you so much.
Thank you.
All right.
Thank you.
Yes. Hi, I'm here with.
Hi, my name is Nita Patel. I'm the Director of Engineering at L3, and I'm with Charmaine Williams, who is Program Manager for IEEE Women in Engineering. She runs the program worldwide, has over 800 affinity groups now, and trying to get more women into STEM.
Yes, IEEE has over 20,000 women who participate in our IEEE Women in Engineering program, and would love to have your university participate and start a local affinity group. So we'll be happy to send you some information, and always contact women at IEEE.org.
Okay, I'm Professor McAllister, so I'll get the word out.
Okay, thank you.
All right. Thank you so much.
Okay, we're going to get started. I know everyone has a 12:30 checkout, so I want to be prompt. So I have the pleasure of introducing this year's IEEE President, Jim Jeffries. Jim?
Thank you. Thank you. Well, thank you for inviting me to be a part of this great event, and also special thanks to the organizers for a great event that you put on. Now, you've seen some amazing speakers over the last day and a half. I mean, they had both high-quality content and they also had thoughtful insights that were very helpful. It's probably as good as a conference I've seen like this in a long time. So special congratulations to the organizers. It's been a great conference. So it's hard for me to put any additional advice on that. One, for the obvious reason. The other is that you'll never be able to have the career path that I had because you live in a different environment. But I think some of the messages, I just wanted to reinforce a few of the messages that you heard during the thing here. One is the uncertainty of your career path. This is an absolutely critical understanding. Everything that ever happened to me in my career had an element of surprise in it, a pretty big element of surprise. You can't lay out things that are going to happen. Mid-career, I had something that happened to me which had a big impact on my career. And the only way that happened is the largest company in the world decided to break itself up. I couldn't have predicted that. But because the food fight that ensued amongst the managers in that breakup, that created an opportunity for me. So you never know where it's going to come from. So it's a big uncertainty. You have to keep that in mind. And the importance of having your hand up, because the reason that was happened to me was I never thought it would be a possibility, but my hand was up. And so when it did, the explosion happened, your hand was up. So that talks about being visible and being out there and presentable. And taking a risk. The biggest mistakes that I made in a career were not taking some opportunities that came my way because I didn't think they were good enough. I didn't think that's what I wanted to do right now. But I look back on it and I say, if I had taken that opportunity, it would have prepared me for some very important things later in my career. And so I missed an opportunity. So taking the risk, being visible, having your hand up, being confident about all those messages, and they came through very strong from the speakers who were here. Those are all critical parts of career opportunity. But I want to take just a few minutes this morning and talk a little different tack than you may have heard before. Professional societies and the role in society, and particularly maybe in the context of what we're talking about here at this conference. And think about the fuel of IEEE. IEEE as an organization, we're the world's largest technical professional organization, but our strength is driven by our volunteer base. So our volunteers that create the value of IEEE. They're the ones that write the papers, that edit the journals, that put on the conferences, that take the time to organize these kinds of events locally. They're the ones that publish, review, edit. They're also the ones that consume a lot of the value of IEEE. So members are what we're all about. We are basically a member-led and a member-centric organization. We have strong staff support, excellent strong staff support, but we're basically member-led. So we're always out there building communities, doing standards, educating in the spirit of collaboration. So professional society like IEEE has a unique place. And when I think about the opportunities, in addition to the things that IEEE is, so we have geographic breadth. We have 400,000 members in 160 countries. We have 100,000 student members. We have a deep technical breadth, 46 societies and councils, and leading journals in the world, the leading publication database in the world. So we are, coming from that point of view, we're a leader in standards. We also have a mission of advancing technology for humanity. This isn't a mission that members, potential members, talk to a business, to talk to a company. Our brand is power, open doors. We have a powerful brand. That's what we're all about. But we're also about our values. And what makes IEEE such a strong and strengthened organization in the world is our value base, our code of conduct that applies to every member, our commitments to things like diversity, our commitments to things like ethics, our commitment to these things. The fact that our journals and our publications have all been peer-reviewed, which is why our journals are the top cited in the world for patents and the top cited in the world in leaders in any one of their categories because of that strength. And so values are an extremely important part of IEEE too. So professional society has a unique opportunity. And I talk unique opportunities because we also provide a different forum. This forum, this isn't a company, this is a different forum. And we provide a breadth. We have student members. We have young professionals. We have mid-career people. We have life members, who are retired. So we have a whole range. And so we touch our members in multiple ways. Every member of IEEE is connected geographically through a local section organization. Our section chair right here from Long Island and happens to be subsection, there's a local geographic connection for every member. We have technical society connections. So you can join in one of those technical societies if you have an interest in that area. About half of our members do join a society or multiple societies, half do not, so it's not 100%. And then we have affinity groups, a third point of connection, Women in Engineering, Consultants Network, Young Professionals. These are affinity groups that are other special interest groups, so there are many ways that we can touch across a broad range. And this is what's unique. And you think of the leadership opportunities that presents, because I say we are a volunteer-led organization. So for each of you, there are so many touch points. You think of a society, we have 46 societies. Some of them have 25 committees. Those committees have 3 officers each. So you see how the math begins to happen and the opportunities that a professional society can play in this role. So professional societies have been around for a long time. IEEE was formed in 1884. I think when Edison and Bell got together and started talking about, they were concerned about this new profession called electrical engineering. It wasn't getting any respect. So it's always been about, developing the profession. It's always been a part of professional society. So not just our society, but all professional society, I think, have this in common. And so it creates a culture of inquiry and brings together diverse experiences. That's always what professional societies have been about. You can talk about things here you might not somewhere else. And supporting the needs of our members and our profession, these are what professional societies have the capability to do. IEEE in particular, has always been about applying our knowledge. And so the reason that we publish, the reason that we have 1,800 conferences all over the world, the reason that we have our database, the reason that we do public policy is to share our knowledge. This is what IEEE is all about. And then projecting our voice. And this is in multiple ways. We certainly have a chance to project our voice as technology policy. When we go to a government and we say, you're planning a major change in technology, you better think about this. But we also have the chance to project our voice. And I know the things that Babak said this morning, a very insightful presentation about where the statistics are. This is a voice that needs to have a broadcast, needs to have a speaker on it. And professional society can and should be doing that. And that's another role that professional societies will play in society. Make that message out there. It's also interesting, IEEE is a global organization. Most of our student members are not in the United States. They're outside the United States. The stats you saw this morning were United States, and we were talking a little bit about, when you go outside the United States, you get a little bit different picture. You see much more participation in engineering programs, just enrollments. I see more leaders. And so as I travel around the world, I see more opportunities and more women in leadership positions, I think, outside the United States. But they have their own cultural issues. So I'm not projecting that this is an answer to the problem. They have their own cultural issues in a different way. So it's very much about being a global organization, having that voice. We're also very much focused on what's next. And my thoughts here are that, when you think about engagement with IEEE, it might be interesting to think about the next generation. We have future directions committees. Increasingly, we have cross-disciplinary issues that are not lining up with our societies. Our societies are kind of closed communities. If you're an expert in magnetics and this type of material or this type of application, that's a very closed community. What we want is open communities. And so we see now we have future directions committees like the BRAIN Initiative, rebooting computing, Internet of Things, big data. So you can join, and so I'm encouraging other thoughts for you to maybe think about joining on the leading edge side, join on the cross-disciplinary side, rather than think of, sometimes it's easier to work there than it is to break into societies or groups. Innovation is going to be an important part. So the idea that we bring innovative ideas all the time to the table. People think that IEEE is the leader in the world in many areas, and we are. Keep that position. We've got to be continually thinking about our innovation and be as innovative and agile as our members are. There's changes going on all the time. You can make a list pretty quickly of what those are. And the way that people connect is changing. The data is exploding.
the capability, people want to self-organize, they don't want to be forced into teams anymore, real teams. So all these are trends that we have to be sensitive to, and so in addition to connecting up technically and connecting up geographically, connecting up innovatively is an important part of the organization. So volunteer opportunities, and I'm putting this directly to you, the opportunity to get engaged in IEEE, advancing our knowledge, networking with others from around the world, and so thinking even beyond where we are right now. Honing special projects, and the skills that are most important actually are the soft skills. They're the only ones that are permanent. The technical skills are not permanent, but your soft skills, your ability to present, and I don't mean just present like this, I mean present yourself. These are important skills. The confidence and presentation skills that serve you well no matter where you go or what you do. So developing those skills is absolutely critical. So the value of membership, as I see it in professional organizations, professional societies have a role to play here. It has a role to play in informing new communities. It has a role to play in representing the voice of those communities. It has a role to play in engaging. But you have to be engaged. The only way to guarantee not to be a part of it is not to be there. So you've got to have the hand up. Inspire participation from fellow colleagues. Almost every member is here because someone invited them at some point. I'm the same way. 10 years ago, I got a postcard in the mail inviting me to get more active in the Denver section where I live, in Denver, Colorado. And I answered the phone number on the postcard, and look where I ended up. So it's always about inviting colleagues, bringing them in, making them part. That's how you build the organization. And we have not exhausted opportunities at all. I mean, I may give you a big list of all the big numbers and all things that we have not exhausted at all the things that we're capable of doing. And finally, celebrating our achievements. This is really important to me, that we celebrate the achievements that we have. That's what makes us lasting. It's what makes us meaningful to a lot of people. So that's my view of membership, the role of professional societies, and this is a great conference. Again, thanks to the organizers. It's really been great. And the challenge here really is maybe to each of you to think about the context. This is just one way. I mean, you heard lots of other things during the course here. This is a way professional society will continue to develop IEEE, to play this role, and look to have you as engaged as possible in this. So look for those opportunities, find the openings. I hear too often from nominations and appointments committee, well, we wanted to have the different committees, but we didn't have any applicants. Now, I don't know if I believe that. It doesn't matter.
Thank you very much, President Jeffries, and a token of our appreciation for coming to the forum is your own personal Arduino box.
So I get to learn the code again.
Yes, you can do.
So I did machine language in 1968.
Oh, that's amazing. We'll get you the sensor, new sensors.
Okay.